First of all, we need to understand that what exactly this is and why this was being created, okay, into the market. So if we talk about a little bit regarding the history of it, okay. So in 2011, okay, Amazon Web Services or AWS came up with a product. They introduced a product within their services. So if anyone have searched ever AWS console, okay, how it looks like, and you have searched what are the services that it is having, way too many services that it has. Within that, that one service which they launched was called as CloudFormation. Okay. Now this particular CloudFormation tool was being used in order to create multiple, or you can say n number of EC2 instances. Okay, I'll take a generic example. EC2 instances. EC2 instances are nothing but servers. Whatever the virtual servers that you want to create for your own use, which are having the CPU, which are having the memory, okay, were used for certain task, for that infrastructure development. So what Terraform exactly is, it's a IAC, okay, called as infrastructure as a code. Okay. And CloudFormation was being launched in 2011 by AWS, keeping in mind that, okay, now let's not do the, you can say that donkey's work in order to create the EC2 instances. Rather than that, what we can do, we can create a template. Okay, we can create a little code. And then in that, hundreds of EC2 instances, if you want to create using that template, you can create it in one shot. So that was a product which was being launched by AWS. After that, within that time only, there was one more tool which was getting created, that is called as your Terraform. Okay. So Terraform was doing the same thing. Okay. And we needed a solution for that because ultimately, if today you have a project in AWS, then it's fine. If you are a cloud engineer and you have a project inside your AWS where you have to create multiple EC2 instances, you can learn the cloud formation ultimately. But after that, what if your project jumps towards your next technology, because you can't be statically defined onto one project more than a year. You have to shift. And at that time of shifting, maybe you can go towards the Azure. Okay. Then Microsoft Azure also launched their own product. Okay. Microsoft Azure also came up with their own product that was called as Azure Resource Manager, okay, also known as ARM. And that was also designing the templates, JSON based template it was designing, which was nothing but running the IAC engine within that. And that was being used to create the different policies and dependencies and define the resources. And in one shot, you can do that. Okay. After that, let's say after 1 or 2 years, you got a new company, you got a hike, but that particular company is using the Google Cloud Platform. Then Google Cloud Platform also have their own product with for that. That is called as Google Cloud Deployment Manager, in order to define that infrastructure. So IAC means infrastructure, and infrastructure in the sense that where we are creating the servers, where we are creating the resources for everything. Okay. It's not what are the policies that are defined for any functionality. No, you are giving a baseline infrastructure to the company. To automate that process, Google started the Google Cloud Deployment Manager. Okay. And also after that, they use one more, which is called as Pulumi, which is nothing but it's a multi-cloud but popular on the GCP. Okay. So this Pulumi was supporting your Python. Okay. So if you are not going with respect to any cloud particular deployment manager, then what you can do is you can either have your Python or Golang or TypeScript, you can learn that, and using those you can do that automation part. So that was launched called as Pulumi. Okay, so many Google Cloud Platform users adopted the Pulumi instead of the deployment manager because they were getting the options over here of multiple programming languages. Okay. Then let's suppose after 4 to 5 years, obviously market is evolving and continuously changing. You can't be starting on one particular technology, otherwise you will be static and you won't be able to get that growth in yourself as per the skill set. So then if you talk about Alibaba, which is again a major cloud platform, Alibaba Cloud, they also have their own product. Okay, which was equivalent of your AWS cloud formation only. So that was being named as Alibaba Cloud Resource Orchestration Service, also known as ROS. Okay, Alibaba Cloud Resource Orchestration Services. In that also you create the template either in the form of JSON, either in the form of YAML. Over here also you are creating the template, JSON template. In Resource Manager also you are creating your JSON templates. Okay. So this was keep on going on. And the engineers, the cloud engineers or the network engineers who are moving towards the cloud networking in order to create this are facing a lot of issues. Okay. Terraform was there, but till 2014, it was not being widely adopted. It was not being widely adopted. Okay. Around in July 2014, the first launch was being done. That was nothing but Terraform 0.1. That was the first version that they have launched. An open source cloud infrastructure or a cloud solution, you can say that. Exactly the idea that was being there with respect to the AWS, with respect to Azure, with respect to the GCP, with respect to the Alibaba Cloud. Okay. And this idea was to start there and extend the automation provisioning workflow to any infrastructure, to any. So Terraform idea was that it can now do the automation of the infrastructure over to CloudFormation also, to Azure also. Sorry, not CloudFormation, to AWS as well, to Azure as well, to the GCP as well, to Alibaba as well. And soon they are going to increase the number of cloud providers. So these are the major tech giants. That's the reason I'm keeping the name. Other than that, you have DigitalOcean, okay, you have Cloudways, there are multiple hybrid cloud providers, private cloud providers. A lot of that are there, small to big. Okay, just like how you have your internet service provider. In India, we have Airtel, we do have ACT, okay, we do have Airtel as well as Geo. These are the two. But after that, these are being distributed state-wise, city-wise. You are going to get many multiple ISPs, which are smaller ISPs, private ISP. Okay, and there are certain companies, small to big companies, who are giving you the internet. So directly, not everyone takes the Geo connection or ACT connection or the Airtel connection. Sometimes people are using the local connection which are there for that particular city. Every city will have its own. Okay, so people do that so that ultimately they can have local services which are quickly resolvable. Ultimately, those are connected to these bigger services only, to the bigger ISPs only. Okay, any private or small ISP is connected to, let's say, Airtel, or it's connected to your Geo. But these are not so big service providers. Okay, so that is one reason. So Terraform was something which was launched in order to give that automation part for all the cloud providers. But in 2014, it was not majorly, I'll say, adopted. Okay, people didn't adopted that. So after that, what happened? That an year came by end of around 2016 end. Okay, after 2.5 years, once after your first release of the Terraform, so there were over certain contributors, around 500 to 700 contributors were there, and dozens of provider, including your Microsoft, GCP, OpenStack, and more. But this number of downloads of Terraform was decreasing. Okay, and finally it was static, and after that it was starting to tick. Okay, slowly your downloads got started of the Terraform when it has given that many options. Earlier, it was only giving the option with respect to the AWS initially, but obviously, in order to make a market and able to make that name into the market, they have to increase the number of cloud providers, and that's where around that out after 2016 they got a big hit. They started having finally people started adopting your Terraform, and that was going double every month. Like in 2017, if you talk about, it was going like a boom. That was called as a year of Terraform, you can say that. Okay, so downloads were continued, usage was continued. That's when also a reason that you can say behind this success was the Microsoft acquisition. So Microsoft acquired this technology, Terraform. Okay. This was being created by someone else. That name of the person was uh, Hashi Nakamoto. If you search Terraform website, the name of the product itself is called as HashiCorp. Okay, the name of the company. If you search over here, let's say if I go and you search about the Terraform website, see HashiCorp. Okay, so this is the name. It was adopted by Microsoft later on. Okay, you can see that now it is being providing the code templates, hands-on tutorial, everything, HashiCorp, Terraform, Docker, Oracle Cloud, you have Azure, Amazon Web Services, Google Cloud Platform, Alibaba, different are there. Okay, so the name of the person was Hashi Nakamoto. Okay, so from 2018 to 20, then they focusing on commercializing this particular Terraform, and then they released again a version 0.12, and after that slowly your version got increased. Okay. So this was the story actually behind the Terraform, that other cloud platforms were using their own product, but the person itself who is working on that technology, the engineers who itself themselves are not satisfied with that part, because they always have to learn a new technology in order to work on that. Okay, but now you don't have to work on this. Using the Terraform, what you can do, whatever the resources that you can gather from the different products, based on that you can create and you can work upon different cloud platforms. And then slowly you can see that in 2022, 2024, 2025, it has been so successively growing that it started making its market into the networking industry as well, where it is having with the Kubernetes, where it is having its own infrastructure with respect to ACI, okay, and the different Cisco products, NDFC and our NDI and NDO, that is working everywhere along with everywhere. Several integrations are being possible with respect to the Terraform. Okay. So this was the story behind that. Now, in that case, your Terraform used a language. Okay. What language Terraform use? So basically, that is called as your HCL. That is called as HCL. If I go over here, won't be provided. I think API call, fine. That is absolutely fine. Okay. HCL is not there. Okay, no problem. We'll read over here. Okay. So Terraform was using its own domain specific language. Okay. Terraform within itself was using its own domain specific language, DSL. The name of the language was SCL, HashiCorp Configuration Language. This is what it was using. Okay. So HCL was very human friendly. Over here, the syntax just look like the JSON format, easier to read and write. It supports variables, modules, conditionals, loops. Again, that same concept, whatever we have studied in Python, condition, loops, variables, module, everything comes, but in a different way of writing them. Okay, and in a easier way. So you can mix your HCL actually with the JSON. Okay. So HCL was very simple. Strength was there because it was purposefully built for infrastructure as a code and not the other things. Now let's come over here in order to read. Let's go through a PPT. Okay, recently I created this. Okay. So Terraform infrastructure as a code can be thought of as a resource an application runs on. Okay, IAC infrastructure means that a resource on which your application running on. Today, your laptop infrastructure is going to be that what is your operating system that you have, how much RAM that you have, what is the SSD storage that you are having, and how many number of cores that you are having in your laptop. That is your infrastructure. So traditionally, this was composed of servers, storage, and the networking. But with the advent of your virtualization, servers were now split into both physical resources as well as virtual machines. Correct. Earlier, you used to have only physical servers usage, but now virtualization has came into the picture. So cloud providers created the additional abstraction, starting with your infrastructure as a code, then moving upon platform as a service and your software as a service. So every cloud platform, all the cloud providers which are there, small or big, they have their own three methodologies or the abstraction layers, which are called as IaaS, PaaS, and SaaS. Infrastructure as a service means where you are actually creating your infrastructure. That is called as IaaS. Okay, so there are three resources which you can see. IaaS, I'll change the ink to white. Then you have PaaS, then you have SaaS. And even these cloud providers are charging in a different way for what are the services that you are going to use out of three. If you are using IaaS, the charges will be pretty much, I'll say, less, because whatever the compute resources that you have asked for, they have given that, and those renting services will be on, and they will be charging accordingly. Okay, so you know that in all the cloud providers today, earlier we used to have pay per hour module, but now they have reduced it to pay per second module. So for every second that you are using your servers, you will be charged for that. Okay, which is more good because more micro segmentation. Sorry, I'll not say micro segmentation, but more lookout has been done over here. Okay, if you are using only 25 minutes of the server, then it is only going to charge for 25 minutes, not 1 hour. If you are using 1 hour, then it will be charged for 60 minutes. Earlier, even if you are using 20 minutes or 30 minutes, no matter, it was charging for 1 hour or 1 day. So pay per day, pay per month, pay per hour module. Now they have reduced it to pay per second module. Okay, years back, it's been like 4 to 5 years since they have started the pay per second. Okay. So whatever, let's say 4 core, 4 CPU, apart from that 8 GB of RAM, and apart from that, let's say 40 GB of the hard disk or the SSD that you have used. Only whatever you are using and how much you are using, you have to pay for that. Okay, but infrastructure will be done once. Now many cloud providers are there who will not allow you to reduce your compute resources based upon your usage. Okay, so definitely that you have to little bit read from the documentation that for your own deployment what is the correct one. If you are going for, let's say, a website development, okay, you want a project, you want to release your own website. In that case, if you are running the AWS, for that 2 core would be enough to run a website. If you think that your user which are there are very limited, like only 10 to 100 500 users are there, but if the users are increasing on top of that, then you have to use more resources. Let's say earlier what we were using in our portal, we were directly giving the recordings of the lectures from the portal itself, from the website, which is nitishsharma.com. So from that, we were facing the issues. What issues? Because over there, now understand, website is becoming heavy. Okay, because every time a user is going to come to the website, is logging in, he's watching the videos. In that, your video streaming is being done. Okay, your video streaming was little compute resources, which was going high as per the compute resources. So in that case, I have to increase the number of resources into the compute that I have rented from the server, from this from this cloud platforms. Okay. Now over there, I was not able to reduce it. If I have removed now all the videos from there, and I have a different lookout of sending the videos which are not being utilized now by the candidate, so I can't reduce from 4 to 2. Okay, I can scale it up. I cannot scale it down. In some providers, I'm saying that. Not all, in some providers, this is still there. So accordingly, you need to check that what is the provider, what are the compute resources that will be a best fit. That obviously with the research you will get to know. Okay. Then, so charges were little less over here. Then coming to the platform as a service. Now they have given you the compute resources, a naked server, let's say they have given you. On top of that naked server, then you want to install Windows operating system, or you want to install Mac OS, or you want to install a Linux distribution. In that Linux, you want different flavors. Let's say you want RHEL or you want Ubuntu Linux. Okay, whatever you want as a platform to be running on that. For that, you have platform as a service. So this particular service now will be taken care of these cloud platforms like AWS, Azure, GCP. So obviously, if their engineers are working on your platform and giving you, basically they are installing the Windows or the different operating system for you, so they are going to charge little high. So charges over here will little bit increase as per the services that you are having. Because apart from a naked server, they are also providing you these services. So they are not just giving you the land. On top of that land, they are also creating a structure, okay, which is nothing but your home that they have created. So for that, more charges. Then comes your software as a service, SaaS. Software as a service defines that on top of your Windows operating system, what are the other tools, what are the other technologies, what are the other softwares that you want to run. Let's say you want to run Zoom on that, you want to run a streaming platform on that, you want to run a VLC media player on that. Okay, so now all of that software part, their data part also will be taken care of by the AWS engineers or GCP engineers or Azure engineers. So they are giving you full service end to end. Now over here in the SaaS, let's say you know nothing and you are not going with anything, you just told everything to the cloud providers, and they are the one, their engineers are the one who are going to help you out for end to end deployment. In that case, your charges are way too high because everything you have given to them, you have outsourced your complete project, starting from infrastructure, then your platform, then your software itself. So over there, charges will be too high. Obviously, if you are taking the services, you have to pay good amount. So these are your three additional abstractions which they are talking about. Infrastructure as a code is a practice of defining and provisioning the infrastructure resources through a machine readable format. The infrastructure provisioned and managed using IAC can include your bare metal servers, your virtual machines, your networking resources, your storage volumes, and even the database provided as a service. Okay, database also provided as a service. What kind of database that you want to use? Let's say you want to use MySQL, MSSQL, MongoDB, PostgreSQL, NoSQL. There are multiple databases out there which are running into the market. DBMS, database management systems. While IAC is often used in multiple cloud environment, it is not necessary to use the cloud for IAC. As long as your infrastructure management system has a programmatic interface, it can participate in the IAC. Infrastructure as a code, that means development of the infrastructure with the help of the code while writing the code. That is how your name comes into the picture, IAC. Okay, that you are doing the deployment of the infrastructure, but rather than going on to that each product, you are doing via the code. What type of code? Again, Python also comes in IAC, Terraform also comes in IAC, this CloudFormation templates, okay, Azure Resource Manager, everything comes under your IAC only. Now, this format can be declarative, defining the desired outcome, or imperative, defining the process of provisioning. Declarative provisioning solutions, such as your Terraform, are focused on the desired end state of the deployment and rely on interpretation engine to create and configure the actual resources. Okay. Apart from that, imperative provisioning solutions such as your batch script focus on the actual provisioning process and may reference to a file containing a list of settings and the configuration values. Okay. Now, what exactly this means? Okay. What is the meaning of your declarative and imperative? Okay. So let's understand that. Now, coming over here again once. Okay. Declarative, which is also the style of Terraform. In the Terraform, you are going to use the declarative approach. You declare the end state that you want. You don't tell your Terraform the step-by-step process. That is called as declarative method. So in the Terraform, you are not going to tell the step-by-step process. That kindly, first of all, log in into AWS, then go into the service which is called as EC2 instances. Within that, check out all the instances, filter the compute resources, what I have given you in the code, and based on that, you create that. A step-by-step process has not to be done. Simple. Terraform is going to figure out how to reach that particular state. You don't have to show the path to the Terraform. Okay. Normally, we create a path for everything that if I want to automate the task, how I'm going to do. Let's say in the Python also, we created a path. We went that, okay, we have to go, first of all, we have to connect using the SSH. that SSH will be connecting to the device, will help me to connect to that device. And after that, I'm going to use that NetMiko library in order to perform the automation or performing any kind of script into uh, the devices, whatever the devices that you are using. Okay. Declarative approach in the sense that you don't have to define the state that how you are going to reach over there. Terraform is going to take care of its own automatically. Okay. So for that, let's say how you write the code. If I give you a small example, let's say you are providing a resource to that. Now, what is the resource over here? I'll tell you in the Terraform. But as of now, let's say you are creating a resource and the name of the resource you have given as AWS instance, that you are creating a AWS EC2 instance. Okay. Example. Now, within that, you are going to use AMI. Okay. AMI 1, 2, 3, 4, 5, 6. Apart from that, instance type you are giving t2.micro. Okay. Now, whatever that instance that you want to create in the AWS, there are multiple type of instances. Okay. If I show you the instances, based on that, you will be automatically be able to understand what I'm trying to tell over here. AWS instances, EC2 instances types, uh, comparison. If I go over here, now see, these are all the different instances that you are having. A1, sorry, A1, 2x large, 4x large. Now see, these are the name of those particular instances which are providing you these many memory. 16 GB memory you will find, 8 vCPUs you are going to find. Storage will be EBS, network performance up to 10 gig. On demand, this is your hourly, this is your hourly, and this is your hourly. Linux spot minimum, Linux reserve cost, on demand, Windows on demand, unavailable. So certain certain instances will not be available for Windows or other. Certain will be available for the Windows operating system as well. Okay, depending upon what type that you are taking. Now over here, see, then you have, these are the large, then you have medium, large, medium, large, and then at last, if you come down little bit, you have one instances which are called as micro also. So these are that many instances that you are having, guys, and it goes up to, like you can see the example you can see over here, 96 vCPUs, R58 24x large, 768 GB of RAM, 96 vCPUs, EBS only, 20 gig of the ports, and these are $5 that they are going to charge hourly from you. If you are doing Windows on top of that, 9.8 hourly that you are getting. Okay, these are the charges that goes, and it goes like anything. Okay, coming down more, then now see over here you have large, 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 all are large only. Okay, if I filter the name as micro, now see, these are your T2 micro, T3 micro, T1 micro. So what I explained over here, that I am trying to create an instance type which is called as T2 micro. This T2 micro, 1 GB memory that you will be getting, 1 vCPU, okay, low to moderate, and you can see that hourly charge. It is bare amount, like most probably it will not be around 5 rupees, 4 to 5 rupees, I think, that they are charging if I talk about in INR, or less than that. Okay, so this is how you create a resources. Now you have not said that how you need to reach it. You have just created a resources of the AWS instance, which has the name as example. The AMI is 12345 6, and the instance type is T2 micro. Okay, so you want just to create an instance. And what is this AMI? So you can again search that. I forgot the full form for that. I know the meaning. AMI in AWS. Okay, yeah, Amazon machine image. Sorry, Amazon machine image. So these are all your image types. These are all the different machines that you are having. Okay, so these are your AMIs. Amazon machine image in the AWS is a pre-configured template for the virtual server EC2 instances that includes the operating system and the pre-installed software, allow users to launch their virtual machine with a ready-to-use software configuration. That means, let's say you have given that, okay, 2 core is fine and that is fine. After that, within this, it is also being given, see that what is the operating system that you can install in that, on top of that. So you can just tell to that AMI, and after that, it is going to create a product for you. It is going to create a resource for you. So whatever that AMI value is being there, that you have to give. Okay. So you are just saying that I want an EC2 instance with this AMI and with this type. Terraform decides how to create it, update it, and destroy it automatically. Second is your imperative mode, on which your Terraform is not working. What is the meaning of imperative? Manual style. You can say that it's a manual approach that you are taking. So you in that you give step by step commands. You control that how the things are going to happen in what order, but rather than you going to the GUI product, you are just telling into a code, into a script that okay, you directly first of all go into that, you create an instance, this is your ID, you are running all the parameters, so you are running this command to launch, and then again if you want more tags into it, you always have to add it more details into that. So Terraform doesn't works on the imperative approach. Okay, so simple analogy. Declarative is just like you are just giving a restaurant order. You are telling the waiter that okay, I want a cheeseburger. So the chef is going to decide the steps that what grill patty he wants, what is the melted cheese, toasted bun. Okay, what are the different things that he's going to decide. Whereas imperative is nothing but cooking yourself, that you are by yourself cooking, first of all heating up the pan, then grilling the patty, then put the cheese on that and toast the bun, and then create a burger and eat by yourself. By that time the burger will be getting cold. Correct. So Terraform works on declarative approach. That is the meaning of the line which is being written over here. Okay. Advantages of using the IAC. So by defining the infrastructure as a code, the deployment of that infrastructure could be consistent across multiple builds and the environments. When the same code is used to stand up the infrastructure for staging and the production, the operations team no longer have to wonder if the two environments are at parity. If you talk about in a cloud context, use the same code to deploy the infrastructure in multiple regions. Make sure that each region is set up consistently. And you can see this picture where your practitioner is there. He is using the IAC, he is planning, he is applying, and after that, deployment can be done on multiple servers on the multiple cloud platforms, AWS, Microsoft, GCP, Kubernetes. Then you have uh, this one, I also don't know, this sign I have seen earlier, but I don't remember this. Okay, I think Hostinger or any other. After that, you have VMware, you have different products are there on which it can do the automation for that. Okay. Simple code to deploy the infrastructure in multiple region consistently. Okay. What makes Terraform different than others? So it's not only the player in town when it comes to working with the IAC tools. Obviously, there are multiple public cloud provider solutions like your CloudFormation from AWS or ARM templates from the Microsoft. Various IAC solutions all have different features and approaches to achieve the goal of automated infrastructure deployment. Many of the public cloud providers out there have some type of proprietary solutions for the IAC specific to their cloud. Terraform is agnostic when it comes to the public cloud. It leverages your providers for different cloud. It is going to leverage the providers for each different cloud as well as the other solutions, including your VMware, Kubernetes, and MySQL. So rather than focusing on a specific cloud as a service, that what I said in the starting in first 10 minutes, that network engineer or basically the cloud engineer were facing the issues of learning that product and their processes for every technology. It's not like it's a half an hour job, understand. If you are learning a product today, you are learning ACI, you will take 2 months, 2 to 3 months in order to do that, and with the continuous rigorous practice as well as learning the concept. Similarly, over here also learning one cloud platform, then running another, because not only you are using or running the Azure Resource Manager ARM, but how that ARM works, from where that ARM is going to pick up the resources. So for that, basically you have to learn many more things inside your Azure format or your Azure cloud provider. So it not only the one product that you have to learn, but behind the scene you have to learn many things so that you can understand that what is happening and how it is being happening. So Terraform is able to provide a common tool, process, and the language, HashiCorp Configuration Language. This is the name of that. HCL was what I said, to be used across multiple cloud and the services. Each time a configuration is planned or applied, Terraform checks to see if there are any changes which are required to the actual environment to match the desired configuration. Okay, so these are certain commands. Okay, what I'm saying, they're planned or applied. These are all certain commands that I'll explain you later into the picture. Don't worry. Without this, you cannot run a Terraform script. Only those resources that require changes will be updated, and all other resources will be left alone. So it is just like, for example, in Git or GitHub, people might have used GitHub. In GitHub, there is something called as a commit. Okay, there is something called as staging in GitHub. Now, what staging and commit wants that, let's say you have created today is Thursday. So on Thursday, you have created a code of 10 lines. Okay, fine. You have updated that code. One commit got created, commit number A. After that, on Friday, what you did, you made only one change in that. For one word, you have added into that script. Okay. Now, again, your complete 10 lines will not be updated. Only with a new snapshot, with a new commit ID B, which is a hexadecimal commit ID that get created whenever you commit the code, only this one new word will be getting updated. So same thing it is happening. Only those resources that requires the changes or whatever the changes that you have done will be updated, and all other resources will be left alone. Simple as that. So if you have created a Terraform script where you have AWS also, Azure also, GCP also, you have for ACI also, or the different product you have for NDFC also. And let's say you have only created the change in ACI and NDFC. Rest 3 will be intact. There will be no again redeployment which will happen over there if there is no change in the script that you have created. Only these two changes will be applied, and rest assured will be left alone. That's a good thing because it is not going to create the script or the execution resource intensive. If there is no change to the configuration, then Terraform will not make any changes to the environment. Simple as that. So state is what allows Terraform to map the resources defined in the configuration to the resources that exist in the real world. It is going to allow to map the resources defined in the configuration to the resources exist in the real world. Okay. Understanding the basics for that. Before you can get started for the Terraform, you need to install it somewhere. You also can't do a whole lot without using the various providers that is going to enable the Terraform to talk to the cloud providers. Now, there is a word called as provider in Terraform, which comes as a keyword also, you can say that, which comes as a variable also that you have to define in your script. So what this provider does it, so provider is nothing but you are choosing over here, or you are telling your Terraform that what are all the providers on which I want to create my script or I want to create the infrastructure. Okay, cloud providers, just like you have like ACI also will be a provider in that case, because you want to deploy your script onto ACI. Okay. You want to deploy your script onto AWS, AWS is a provider. You want to deploy your script onto Azure, Azure will be a provider. So these are called as provider. So various providers that enables the Terraform to talk actually to the cloud providers. If you don't create the providers, how do you think that your Terraform is going to talk to them? Platform services, data center applications, and many more. So there are multiple providers which are there. Either you talk about cloud, platform, data center applications, and more. Terraform itself is being written in Golang. Okay, Terraform using another language which is called as HCL in order to write the script. But Terraform itself is being created or being written in Golang. So there is a Go language in which it is being written. Just like you have Ruby, Python, you have Golang also, and it's being compiled as a single binary for multiple operating system. So you don't have to, actually there are certain software for which you have to download and install multiple binaries out there. Binaries in the sense certain binary files. Okay, those are called as binary files or the codes that you need to execute within that language. But over here, no. Over here, they have actually created a single binary, a single executable file for other platforms. If you want to in Windows, it is going to basically down help you to download a exe file. If you are going with the Mac OS, you can have either DMG file or you can have directly from your homebrew also through the CLI. If you are going into the Linux, you can have other binaries. So over here, installation is very simple. Okay, you can see that you don't install it. Uh, okay, one thing. Sorry, there is no compiled setup script or the laundry list for of dynamic link libraries. You don't install it using an MSI, RPM, or DPM. The executable binary comes under a zip file. Terraform is supported on Windows operating system, Mac, and Linux, FreeBSD, OpenBSD, and Solaris. To install the Terraform on any supporting operating system, find the package for your operating system and download it. Terraform is distributed as a single zip file. After downloading, unzip the package or to a directory you are choosing. Terraform runs as a single binary named as Terraform. Any other files in the package can be safely removed and Terraform will still be in the function. To enable running Terraform from any path, you can modify the path environment variable to include the directory that contains the Terraform binary. That means what it is saying that if you are, let's suppose, in your, if I go over in, so if I go in, not in task manager, what I'll do, if I go in this PC, okay, properties, this is my PC. And in that PC, let's suppose, so these are the compute resources that I'm having. Okay, I don't have a graphic card, but storage, processor, and RAM 56 GB. And if I go within that advanced system settings, okay, at the right side you have the advanced system settings. Okay. So you go over there, then you get into the environment variables. Now over here you can see that there is a path. Okay, there is a path which is being given. Within that path, you can actually add your Terraform file that you want to execute it. Okay, I'll tell you how. So let's say we go on to the website, install Terraform. I'll go over here. Is there package manager, Windows, chocolatey on Windows, manual installation, compiled from the source for the Windows. It should be giving a file path, not giving. Okay, I'll go to the Terraform directly, install this. Now see, ARM64 versions are being given. These are the binary getting downloaded. Windows binary, AMD 64, 386. So 64-bit architecture. For that, you will be downloading that. Okay, let's say you have downloaded and the file got downloaded, the zip file. Okay, now what I'll do, I'll just open that zip file and within that, see, directly I got terraform.exe. Okay, I got terraform.exe. Now I'll extract to, let's suppose, C downloads, and I'll just copy this. Okay, this is where the file got extracted. Okay, or I'll say I'll create a new folder where I'll create inside, fine, inside my D drive. Okay, and over here I'm going to create a new folder, and the name of the folder is Terraform. Okay, I'll copy this path, create the Terraform, done, and click on OK. It is going to extract that file over there. Okay, now what I have to do, I'll go into my environment variables again, this PC. I'll go into the properties of this PC, advanced system settings, environment variables. I'll define the path. I'll create a new path and I'll give this path Terraform. Okay, I've defined it. So where the Terraform is installed, basically in my D drive right now, and it's an executable file. If your exe setup is getting installed inside your, let's say, downloads folder, so you will only be able to execute from the download folder. But once you add the path, now from anywhere you can install and you can run your Terraform. You from anywhere in the complete computer, in the complete laptop that you are having, anywhere your Terraform is installed, now you can run that. So if I open up the command prompt over here and if I write Terraform, now see it is being running. Okay, I can't see which Terraform, which is not going to work. Find Terraform, find is going to work, find parameter. Yeah. So I don't know that how it is going to have it. PWD Terraform. No option. Okay, no problem. But this particular Terraform is being installed into my D drive, into that folder, but I am able to run anywhere. Right now I am into C users. You want me to go into the F drive? I'll go into the F drive. Or from here also, If I write Terraform, see, I'm able to run that. So from any location I can run. So basically, wherever your project files are being there, wherever that you have created a directory where you want to run the code or you want to create the files, you can directly install, sorry, not install, run the Terraform from there. Simple as that. Okay. That is the magic for path variable or the environment variables. Then talking about the providers. The resource and the data sources used by the Terraform are all enabled through the provider system. A provider is an executable plugin that contains the code which is necessary to interact with the API of the service it is being written for. Okay, so whenever you are defining a provider, let's say over here you can see the example in this picture, you are actually defining a provider. Okay, the provider is Azure ARM. Now within that provider, you are defining the version. The version is 1.41. The tenant ID is variable.tenant ID and the subscription is variable.subscription ID. So you have to create a provider. Okay. So just like that, you have to create for ACI also if you want to run the IAC tool for the ACI tenant creation, VRF creation, bridge domain creation. So it's kind of that plugin that contains all the code that is necessary to interact with the API of the service it is written for. Typically, this includes a way to authenticate to the service, manage the resources, and access to the data sources. If you want to see that how the provider is being created for ACI, again, Google search is the very best thing over here. I can write it down, no problem, but still. So ACI, uh, Terraform provider, and you'll see a code which is being written. See, Cisco DevNet/ACI. Okay, this is how it is being given. This is your provider. Name of the provider is ACI. Within that, you are giving the username, admin, password, and URL. Now see what is being written over here. Providers, sorry, the first line if you see, typically this includes a way to authenticate to a service, manage the resources and access the data service. How your code is going to interact with that particular API and authenticate it. That's the reason you over here you are giving the username, you are giving the password, and you are giving the URL that okay, this is my. So URL you can give your IP address of the, let's say my IP is 10.1.1.51. I can give that username and password, whatever the credentials are there for my ACI, I'll give, and this is the provider. When I do this, it is going to do what? In this method, it will obtain an authentication token from Cisco Apex and it will use that token to authenticate. A limitation with this approach is Apex count the request to authenticate and threshold it to avoid the DOS attack. Okay, why it is going to ask a token? So that you don't flood the request, multiple authentication requests, and ultimately it can create a DOS attack for that. After too many attempts, this authentication method may fail as a threshold. Threshold means once you have uh, reached to that limit, to that upper limit where now it is not going to accept and it is going to throw you an error with respect to, let's say, rate limiting. Okay, rate limiting is the best practice to avoid the DOS attack. That once your rate are being limited, rate of execution will be exceeding, it is going to limit for 1 month, sorry, for 1 minute or 2 minutes or even a 1 hour. To avoid the above mentioned problem, Cisco Apex supports signature based authentication. So you can have your signature based authentication as well. This is again a provider. So provider is ACI. You have just given a name to that provider, username, admin, private key. If you have any private key of the Apex, you can generate that and you can give it to that. Cert name is this and the URL again. Now it is going to have the signature based authentication. Authentication with the local domain, login domain and the password. So this is your login domain. Okay, you are going to give the password URL if it is being deployed online. Okay, and you are going through a domain or you are entering into the ACI, so you can go with that also. Okay, so this is how you create a provider. So let's say now this is your complete code. You go into the Terraform required providers. So required providers is nothing but where you can create multiple, not only ACI. I can create Azure, I can create AWS, I can create. So I have created one variable called as required providers in which now I'll create multiple providers. But over here, we are taking the example of one which is called as ACI. The source for that is Cisco DevNet option ACI. This is the source. This is how it is going to interact with your service, with your ACI. If this is being written wrong, you are gone. Okay. Let's say if you search over here, Ansible NDFC host YAML, Ansible NDFC host YAML. Okay. Introduction NDFC with Ansible Learning Lab. If you are creating an Ansible code, for example, I'm just giving you an example over here. Okay, set up the environment, everything is being done. Yeah, this always comes into the picture. Okay, now see cisco.dcnm.dcnm. This is your plugin, guys. This is the Ansible DCNM HTTP API plugin through which it is going to interact with that NDFC. Otherwise, it is not going to interact. If you have given cisco.dcnm. something else, any name, it will not interact. It is not, it doesn't know that how I need to interact or how I need to connect with that particular service. So these plugins names you have to give it very properly. And over here also your Cisco DevNet ACI is working like that. So it's a plugin, you can understand in that case, which is coming as a source. Then provider, ACI, username, admin, URL, insecure, true, resource. Then you are creating a resource. Resource means what actually as an infrastructure that you want to create. Now over here, what it is creating? It is creating a tenant. You can see that. Okay. These resources are also fixed. If you go into the resources, let's say over here, these are your ACI REST resources. If you want to create a tenant, see ACI REST for REST L3 external out, L3 out. So now you can understand because this is your terminologies as a network engineer. You want to create ACI REST, let's say made by REST YAML. This is a different one. You are creating a sales main ACI unit. Okay, fine. Apart from that, path, class name, content, payload, DN. So these are, I'll tell you how to create these data resources. Okay, so you can actually create a resource where you can go under your ACI, you can create your VRF, you can create your tenant, you can create your bridge domain within that through a script. You can create multiple out there in one shot by running the script once being done. Okay, so that is the meaning overall for this line. Providers can be explicitly defined within a configuration or implied by the presence of a resource or the data source that uses the provider. The actual arguments in the provider block vary depending upon the provider, but all the providers support the meta arguments for the version or the alias. So all the providers are going to support the meta arguments that you can directly write it down. You don't have to, you just have to directly search the documentation for that particular product and you will be getting all the information from there, put it into a JSON format and use that. So this is how your AWS is being given. You can see that. This is how it is being written. For the ACI also, you can see on the left side, I have given a picture. Terraform required providers, ACI, source is this, version is let's say 2.0, specify a version constant. If you are using 5.x, we'll go with the version for that accordingly and will create a provider. And with that, your Terraform will know that how I need to connect. Okay. Guys, till now everyone is clear how to work on this. Little bit got an idea what exactly it does. So little bit easier, I'll say that, than Python, because over here your resources and the documentations are readily available, and you just have to read it properly, and you should know that how JSON is being written. So you have already seen the lectures that way how you create the dictionary. So it is easy now to create the JSON language, and then your Terraform deployment will be pretty much easy. Okay. So this is a top line overview that we are having. We'll go more into the de detail into that and we'll start creating the code also line by line. We'll understand the complete CLI of that, that what are the different options that are being given over here. So if you run the command called as Terraform, what are the different option, console, FMT, okay, then you have over here init, validate, plan, apply, destroy. So these are the main 5 commands that you have to do for the infrastructure creation or deletion. What is the version that you, so you can directly give the command Terraform version. It is going to show you the version 1.13 running on Windows AMD 64. Okay, so these are different things. Will be installing, how you need to install the modules, upgrade the remote modules, everything. We'll see that. Okay, so this is what we have for today's session. Now with that, let's wrap up for the day. We'll see you tomorrow on Friday and we'll take the things further ahead. Okay, thank you all for joining. See you tomorrow, guys.